So this is area between two curves. So what if we have these curves, the yellow one, y is equal to g of x, and the pink one, y is equal to f of x, and we want to get the area between them. So to represent all the rectangles that can be drawn within this area, so we draw a vertical strip, or we can also use horizontal strip. Okay, so if we're going to use a vertical strip, then its thickness would be dx, right? So let's say this is the vertical strip that would represent all the rectangles that we can draw within this area. Okay, so the thickness of this vertical strip is dx, and its length, take note, it's no longer equal to just equal to y because we have two curves, and y is the distance between the x-axis and a point on the curve. So to get the length of this vertical strip, so we need to get the y of the upper curve, which is the pink curve, okay, and the lower curve is the yellow curve. So this distance, okay, the distance of the upper part of the vertical strip is measured. If we measure it from the x-axis, so it's y, okay, of the pink curve, okay, or we label it as y sub u for upper. And for this one, the distance between a point on the yellow curve and the x-axis, so if we're going to get this distance, so this distance would be the y of the lower curve, which is y is equal to g of x. So the length, therefore, of the vertical strip, the length of the vertical strip, the length here, okay, that's equal to the difference between the upper and the lower y values. Okay, so the thickness is dx and the length of the vertical strip is y sub u minus y sub l, u for upper and l for lower. Okay, so this would be the integral expression that we are going to evaluate. Okay, and the limits must be x value since our variable of integration here is x. So it should be the abscissas, okay, or what we call the x coordinates, okay, of the intersection of the two curves. So we have here A, let's say AC, okay. A is the abscissa of this intersection point here, and C is the ordinate. And if this is having the coordinates B, D, okay. So we should evaluate the integral from the x value of this intersection point and the x value of this intersection point. Okay, because again, we are evaluating with respect to x, so our limits must be values of x. Okay, so if we're going to have a horizontal strip, just similar to that, so its thickness would be dy. So this is the strip. Okay. Uy. So just imagine na lang na straight na siya. Uy, di siya rectangular. Anyway, basta this would represent all the rectangles na in this area between the two curves. Okay, so its thickness is dy and its length, okay, this yellow curve has a greater value of x compared na to the pink curve. So the distance between this point on the yellow curve and the y-axis is basically let me extend. It's basically the x of the yellow curve. So this is x sub r for right, since the yellow curve is to the right no, of the y-axis. It's also to the right of the pink curve. And for the other end of the horizontal strip, so we get this distance, okay, from this pink curve towards the y-axis. So this is okay, the x sub l, l for left. So the yellow curve is the right curve and the pink one is the left curve. Okay, so to get the length of this horizontal strip, okay, so this distance, okay, the length of the horizontal strip, therefore, is the difference between the x sub r and x sub l values. All right, so we use that in this integral equation, okay, with limits from c to d. So we are evaluating with respect to y, so our limits must be y values. So similar to the one above, okay, so if the intersection point coordinates here, at this point here, okay, are A, C, and here B, D. So the y values are C and D. C and D. So evaluate from C to D. All right. So for example, find the area bounded by these three lines. Okay. Y equals 2x plus 1, y equals 7 minus x, and x equals 8. So these are all linear equations. So we draw three lines. So let's start with the first one. Y is equal to 2x plus 1. So we use the intercept so that we can easily plot the points and draw the lines. So for the first line, so at x equals 0, so just cover the x term. Okay, so if x is 0, so again, you just cover, okay, this term here, since this will be equal to 0. So y is equal to 1. Okay, y is equal to, sorry, y is equal to 1. Okay, and for the second intercept, this time 0 for y, then solve for x. So if y is 0, then we transpose the 1 to the left side of the equation. So it's negative 1 equals to x, or that's negative 1 half. Okay, so negative 1 half for the x intercept. For the second line, different color. Okay, so if x is 0, y is 7, and if y is 0, then x is also 7. right? If x is 0, y 7. If y is 0, x is also 7. And for the third one, it's x equals 8, so there's no y term. So meaning it's either a horizontal line or a vertical line if there is no other variable. Okay, so since x is equal to 8, so meaning all the x values of the points in this line have or is equal to 8. So meaning it's a vertical line, okay, which passes at the x-axis at 8. Okay, so I have 8, 1, 8, 2, 8, 3, 8, 4, 8, 5, 8, 6, 8, 7, etc. No, for the points on the line. So we now draw the lines. So y is equal to x plus 1. So we have 0, 1, and negative 1/2 0 is here. So just connect the 2 points and then you draw the line. Okay, so show me this is already a straight one. Okay, so this is for 2x plus 1. Y is equal to 2x plus 1. Then for the yellow one, so we have 0, 7, to 0, 7, and 7, 0 is here. So we connect the 2 points. Then we have now the line. So this is y is equal to 7 minus x. And the third one is x equal to 8. Okay, so I need to extend the pink curve. So yeah, let's draw first the x equals 8. X equals 8. So this would be the x is equal to 8 line. So the area that we need to solve for must be bounded by these three curves. Okay, so we need to extend the pink one. Assuming that this is already a straight line. And we need also to extend the orange one. Wait, orange one. Okay. Okay, it's not straight. So assuming that this is already a straight line. So this area bounded by the three lines, it's actually a triangle. Okay, so we need to solve for this area. So what should be okay, the type of strip that we need to use? Okay, so if we're going to use a horizontal one, okay, if we're going to use a horizontal strip, okay, so for example, this is the horizontal strip. Take note that if you draw a horizontal strip on this part here, so you have the orange and the pink curves. Okay, if you draw the horizontal strip here at the lower end or the lower part of the curve, you have the orange and the yellow curves. So you're going to use two sets no, of or two horizontal strips with different functions involved. So you need to divide the area into two parts, solve for the area separately, then add the values after. Okay, if we're going to use a vertical one, so let's see if we can minimize the number of steps that we are going to draw. For this part, okay, so the pink and the yellow curves are involved for this part. Also the pink and the yellow curve. And then for other parts, like here, for example, okay, so just the pink and the yellow curves. So no problem with the vertical strip. So it would be the best option, okay, to use the vertical strip. So draw the vertical strip. Okay, if you want to verify if it's really equal to the summation of the areas, okay, if you are going to use the horizontal strip, so you can also do that. Okay, because sometimes we need to do that, not to divide the area into two or more parts, okay, depending on the application. Okay, and also if we go not to the volume of solid figures, okay, after this area, no, between two curves, na topic. Okay, so the thickness of this vertical strip is dx, okay, and its length, okay, so this is y of the pink curve, the upper curve, no, is the pink curve, so y of the 2x plus 1, basically. Okay, so it's the 2x plus 1 for the upper curve and the lower curve. Okay, so it's y lower. So it's for the yellow curve, so it's the 7 minus x. Okay, so the difference between the two values of y would be the length of this, they call this, of the strip. So for the integral, so y upper minus y lower, okay, dx, and the limit that we're going to use, okay, would be from this value of x, okay, here to this value of x. Basically, the x equals 8, okay, or you can also use this point here. So from here, let me use this. From, okay, okay, so from here. So it's from this area, man, not towards the orange line that serves as the boundary, okay, of the area. So from here to x equals 8. So the upper limit would be 8 and the lower limit must be the intersection between the yellow and the pink curves. Okay, the yellow and the pink lines. So how do we solve for this intersection point? Okay, so this is one single point whose x and y values are the same, no, for both curves, for both lines, for both y equals 7 minus x and y is equal to 2x plus 1. Okay, so we can equate the y values or the x values, okay, to solve for the intersection point rather. So the upper limit again is 8 and the lower limit is the intersection of the yellow and the pink curves. So solving for the intersection, solve for the intersection point. Okay, so we can equate no y equals 7 minus x and y is equal to 2x plus 1. So their y values are equal. So equating the two, okay. So let's say this is y sub 1 and this is y sub 2, or y upper, this is y upper and this is y lower. So y values are just equal, so we can equate y lower equals y upper. Okay, so 7 minus x is equal to 2x plus 1. So that's how you get now the intersection between intersection point or points if there are many intersection points. So we have x is equal to 6. Okay, or sorry, not 6. 2. So this is, if you transpose the minus x to the right side, it's 3x. 7 minus 1 is 6. So 6 divided by 3. So x is equal to 2. Okay. We're after the abscissa only, no, or the x coordinate of the intersection point. So you can just skip the y coordinate no solution. So we're after the x value. So it should be okay from 2 to 8. Right? So for the integral, so we now form okay, the integral. So this is the area equation. And by the way, okay, regardless of the location of the area, we have here a small area at the fourth quadrant, no, below the x-axis. Okay, so no need to put a negative sign for the area. So it follows that if you use upper minus lower, or for horizontal strips, right minus left, so automatically, okay, it will yield na the final area. So no need to solve for two areas separately, no, for lower and upper areas, meaning above and below the x-axis and to the left or to the right of the y-axis. So no need to do that. Okay, just follow this okay difference between upper and lower curves and between um to the right and to the left curves for horizontal strips. So we now plug in the y of the upper curve. So y of the pink curve is 2x plus 1 minus y of the lower curve. That's 7 minus x. Take note, this is subtraction. So careful with the signs. So minus quantity 7 minus x, or that's minus 7 plus x. Okay, dx. So we simplify the integrand. So we have 2x minus negative x. So that's 2x plus x. So that's 3x. And then 1 minus 7, that's negative 6. So 3x minus 6. Okay, dx. So you can use a calculator, or if solutions are required, then evaluate the integrand. Okay, the integral rather, 2 to 8 limits. Okay, so if you are allowed to use a calculator, so here's how you input the integrand and the limits. Okay, so it's 3x minus 6. So 3, then the x here is the x above the close parenthesis button. So you press alpha and then the close parenthesis button and then minus 6. So just explore, okay, the functions of your calculator if it's not of the same model as I'm using, okay, in the discussion. So we have 8 and then 2 for the lower limit. So we have 54, okay, square units for the area. So 54 square units. Okay. So 54 square units. Okay, so I cannot see the cursor. So this is the final answer. Now for the second example, so find the area bounded by this parabola x equals 6 and y equals 2. So recall for parabolas, Okay, so this x term is being squared, so meaning it should be in the form x minus h quantity squared equals 4a, okay, times y minus k. Now where the vertex is at hk and the distance from the vertex to the focus or the a value, okay, the distance now from the vertex to the focus is a, okay. So whatever is the what they call this coefficient of the y term, then that would be 4 times a. So we have, so that would be x squared minus 6x plus 10 is equal to y. So we need to express the left side as a square of a binomial. So this is not a perfect square trinomial yet. So let's make it a perfect square trinomial. So the last term should be 6 divided by 2 squared. So that's 9. So we're going to add 9. So meaning we need also to subtract the same amount, same value, no, 9 minus 9. So that it will not change the value of the equation. So it's x squared minus 6x plus 9 plus 1 equals y, or that would be x squared minus 6x plus 9 is equal to y minus 1. Okay, or this is x minus 3 quantity squared is equal to y minus 1. So the vertex therefore is at 3, 1, and the coefficient of y is 1. So for a is equal to 1, okay, or a is equal to 1/4. So the distance between the vertex and the focus is 1/4. And then x equals 6 is just a vertical line and y equals 2 is a horizontal line. So we plot the points. So 3, 1 for the vertex of the parabola. Okay. X is being squared, so meaning the parabola is opening upward and the y term is positive, then it's opening upward. Okay, if it's negative, then it's opening downward. So for this is the vertex. So for the focus is you get the value of a, so it's 1/4. So if we zoom that in, so let's say this is 1/4 unit here. So this is the focus, and then to get the points to the left and to the right of the focus, so you just multiply a by 2. So 1/4 times 2 is 1/2. So there's a point here and a point here. And then you connect these 3 points, and then you'll form the parabola. Okay, or if you want, you can also solve for the y-intercept, or it's not necessary for this example, I think, because we need the area bounded by x equals 6 and y equals 2. So x equals 6, that's a vertical line passing through the x-axis at 6. So let me extend first the parabola to cover the x equals 6. Okay. And then draw the line x equals 6. So it's this line. Sorry, it's 7. So x equals 6 is here. So rather x is equal to 6. Okay, the pink curve is the parabola y equals x squared minus 6x plus 10. And y equals 2 is a horizontal, okay, horizontal line passing through the y-axis at y equals 2. Okay, so it's y equals 2 for this orange line. So it should be the area bounded by the 3 curves. Okay. So we have here two options actually. Okay, we can use a horizontal strip. Okay, so we can use a horizontal strip because anywhere on the, by the way, these, not these, this is the area that we need to solve for. Area bounded by the pink curve, the yellow curve, and the orange curve. Okay, so we can use a horizontal strip, no problem with the right and the left sides because only the pink and the yellow curves are involved. We can also use, okay, the vertical strip, right? Because ano, okay, pink and orange here, pink and orange here, pink and orange here. Even if dito sa taas, it's still pink and orange, although there's a yellow line, but it's the boundary na. Okay, so it's either a horizontal strip or a vertical strip. So let's say we are going to use a horizontal strip. So that would be different from the first example. Okay, for a horizontal strip, so its thickness is dy. Okay, and the limits must be, okay, from this value of y to this value of y. So this value of y is 2, meaning the lower limit no, is 2. And the upper limit is, we can solve for that by getting the value of y at x equals 6, right? Or, yeah, at x equals 6. Okay, so find the value of y at x equals 6 for the upper limit. Okay, and this point here is basically 6, 2. So the lower limit is 2 and solve for the upper limit later. Okay. And for the length of the horizontal strip, so it should be y sub r minus y sub l. So basically, or y sub l, r, I mean, meaning right. Okay, y sub r is the yellow line. Okay, because the one to the left is the parabola. Okay, so y sub r would be the, no, not y. Okay, sorry, that's x. That's the distance no, from the y-axis. So x sub r, which is 6. Okay, and the pink one would be our x sub l. Okay, so x sub l. So x sub l would be the x from the parabola equation. Okay, so x of the parabola. So we'll solve for that x function, okay, later. So we have already the lower limit. So let's say we are going to solve for the upper limit. To solve for the upper limit. So intersection between the yellow line and the parabola. Okay, so at x equals 6, solve for y. So it should be the y of the parabola. So y equals x squared minus 6x plus 10. So that would be 6 squared minus 6 times 6 plus 10, or that's equal to 10. Okay, so this is 610. So if you are going to draw the curves properly, so you can double check if it's really 10. 7, 8, 9, 10. So medyo hiwi di ang parabola because this is not 10, 6, 7, 8. It's just equal to 8 based on the graph. So maybe the opening is dili kaayo sakto, no? Pagka-draw. Anyway. Okay, so it's just a graphical no representation. Pero if possible, if you can make it as accurate as possible, kana, no, it would be better. Sakto ba? 6 squared minus 6 times 6. So that's 0, no? Plus 10. So yeah, y equals 10. Okay. So our upper limit would be 10. And then for x, or rather for the area na, no? So solve na for the area. So the area is equal to, it would be from 2 to 10, right? Yeah, 2 to 10. And right minus left. So that's 6 minus left na x. So solve pa di ay for x of L. So this is the x of the parabola. So from y equals, okay, so we use na this equation here because we'll be solving for x. So from that equation, okay, so from that equation, squared, sorry, that should be squared. So from that equation, solve for x. Okay, so this is a quadratic, okay, expression. So meaning there are two values, no, of bale here, plus and minus square root of y minus 1. To get the square root of the left side and the right side, it's equal to this equation, the result to this equation. Okay, so we have two values, no, plus and minus. So if you're familiar with mga kanino, radical functions, okay, so which one to use? Is it x equals 3 plus square root of y minus 1, or x is equal to 3 minus square root of y minus 1? Okay, so it's the parabola, okay, which is on the right side. If you draw na the symmetry, to look at the symmetry, okay, so this is the axis of symmetry. So where is the 3 plus square root of y minus 1 and 3 minus square root of y minus 1? Okay, so since it's the x value, so meaning the one on the right side, okay, would be using 3 plus square root of y minus 1, right? And the one on the left side must be 3 minus square root of y minus 1. Okay. So since we are using valid this portion here, the right portion, 8 for the left end of the horizontal strip. Okay, so we'll use the 3 plus square root of y minus 1 because pwede man, no, na the horizontal strip is maabot din ha nga side. Na, for example, this is the horizontal strip. Then the lower end, the left end of the horizontal strip, okay, this point here, okay, would be using 3 minus square root of y minus 1. Okay, but this point here on the right side of the parabola is 3 plus square root of y minus 1. So we'll use 3 plus square root of y minus 1. So that would be minus, take note, subtraction. So careful with the symbols or the operations rather. Okay, dy. So it's going to be 6 minus 3 minus square root of y minus 1 dy, or that's 3 minus square root of y minus 1. Ay, sorry. Y minus 1 dy. And then, sige, you're allowed to use a calculator for this part na. Okay, so, para ma-focus ta on what you call this, drawing, no, the figure, and then identifying, okay, what type of strip to use to solve for the area. So since the default variable in the calculator is x, so we'll replace y with x, so it would be square root of x minus 1. And the upper limit is 10 and the lower limit is 2. Okay, so that's 6.667, or in fraction form. Okay, so it cannot show an answer in fraction form, but that is 6 and 2/3 basically. Okay, so 6 and 2/3, or that's 20 over 3 units. So that's the area, okay, of the curve bounded by the three functions. Okay.